Okay, so 3.2, we're going to look at polynomial functions. So more than just quadratics, we'll have cubic, quartic. I think you even saw a quintic on your preview packet when it has the degree 5. And we're going to describe the end behavior. Of functions. And we're going to determine the local max and min on a graph. So last week we were doing that using algebraic techniques. We talked about the opposite of b over 2a. Okay, so when you are doing the end behavior, this book uses positive infinity. I know that last year they just put infinity, so the plus is going to be your positive infinity, and then the negative is negative infinity. So the values with x, it means that it becomes large in the positive direction. And if it's going to negative infinity, it says x becomes large in the negative direction. Okay, so the positive infinity can mean two things with x and y. So anytime it's x goes to a value, if it's negative, they're asking you what is happening on the left. And if it's positive, they are asking you what's happening on the right. Okay, that is different than when you are using it for y. So if you have a negative on the y, that means it's going down. And then if you have a positive, that means you are going to go up. Okay, so it looks like many of you remembered this from last year. This table is going to give you some examples. Notice that this table is split up into two different sections. So you have the odd degree and you have the even degree. Do you guys remember what happens with every odd degree function, what the ends do? Yeah, yep, good. Opposite directions, and if it's even, they will go in the same direction. Okay? So if your degree is odd, they go in opposite directions. If it's even, they go in the same direction. Okay, the other thing you have to look out for is the leading coefficient. So if you look at this table, they classify, if you have positive, you have this chart and you have this chart. Do you guys remember what the positive leading coefficient tells you? Yep, and it's a specific place. Yep, so if the leading coefficient is positive, it goes up on what side of the graph? Yes, the right side. Okay, so the leading coefficient, I just call it the LCO. If it's positive, it goes up on the right. And if it's negative, it goes down on the right. So it's always about the right side. Okay, so for part A, you're going to be given a polynomial p of x, and then you're going to be filling out your form. Okay, and again, this book does it a little differently than last year's book, but they do mean the same thing. Okay, so if you had a graphing calculator, you could graph that and do it, but you don't need it. Okay, so you have to be able to analyze it without your calculator as well. Okay, you will always need as x goes to negative and as x goes to positive so that you can explain what happens on both sides of the graph. Okay, so the first thing you want to do is pick out the degree and pick out the leading coefficient. So the leading coefficient is negative 2. Okay, so if it is a negative, That means that it falls on the right. Okay, so this is the right side, this is the left side. Okay, so if it falls on the right side, then I can fill in P of x is going to negative infinity as x is going to positive infinity. And then I'm going to look at my degree. Okay, so my degree is 2, and I have to identify if it's even or odd. And if it's even, they're going to go in the same direction. So if it's going down on the right, it's also going to be going down on the left. Okay, so anytime you are doing this, your structure is going to be the same. You're always going to say P of x goes to something as x goes to negative infinity. And then sometimes there'll be an and in there. P of x goes to somewhere as x goes to positive infinity. Okay, and then you can fill in those two spaces based on your equation alone. All right. So I'm going to give you the P of x, and I'll have you guys fill those in. Okay, and feel free to talk with your row. Okay, so we're going to do B and C, and then we'll put those together. Okay, and then Amelia, can you tell me what your leading coefficient is for P? Yes, good, okay. So if your leading coefficient is 1, we know that it's going to be positive. So that means on the right side, it's going to be going up. And then the degree, Michael, what's our degree for this one? 3. Okay, so your degree is always the highest exponent. So if it's odd, we know it's going in opposite directions. So this should be negative infinity. Okay, so you're always starting off with your polynomial. And you're always going to have both sides for x because you have to tell me what's happening on each side of the graph. Each graph has a left side and a right side. Okay, so because that's a negative, it's going to be going down on the right. Because that's an odd, this one will be going up. Okay, so if it's negative and then odd, you know these should be opposites. Down on the right side. So it's always going to be your right side there. Okay, what questions do you have for me on that? Some of us, they're kind of coming back from last year. Okay, because you guys had something very similar. They just started with the x instead of the P of x. and then we are going to be finding zeros. Okay, so when you are finding zeros, some of your directions are going to say to factor the polynomial. So yay, we're going to do some factoring. Okay, so we're going to factor the polynomial to find all its real zeros. Okay, remember what other type of zeros are there? Imaginary. Good. So the real zeros you can see on the graph. Okay, these are the x-intercepts. Okay, those are your real zeros. The x-intercepts on the graph are your real zeros. Okay, so I'm going to give you the polynomial p of x, and I want you to factor following your rules. So remember, when you're factoring, you always want to see what they have in common. Take out that GCF. You can look for special patterns, and then you can guess and check with FOIL. Okay, so I want you to factor for part A. Okay, so then your first step to factor, Ashley, tell me what you did first. Yep, so you factor out the x, that's what they have in common, great. So then you get x squared minus x minus 6. Okay, and then Tristan, what did you factor that down into? Good. And either order is fine. So when they ask you to factor the polynomial and use the factored form to find the zeros, sometimes they're going to ask you for that factored polynomial. Okay, that is the factored form. And then we're going to use that to find the zeros. So what you're going to do is set each factor equal to 0 and solve. Okay, so don't forget to do that, to do the solving part. So each one, okay, is going to be equal to 0. Okay, and I do want to see that step where you're setting them equal to 0. Obviously, there's nothing to solve for here. And then I'm fine if you just move that over, plus 3 minus 2, that's fine. Okay, so your zeros are 0, 3, and negative 2. All right, and then for part B, we're going to have a cubic polynomial with 4 terms. So we have p of x equals 2x cubed minus x squared minus 18x plus 9. Okay, so if there's something that all of them have in common, you can take it out. And then if you have 4 terms, do you guys remember how we do that process? You factor by grouping. Good. Okay, so once you group, then you're going to take out your common factors. I'm going to do that in this step just so that you can see, like when you're looking back at your notes, you can see that. Okay, so you group and then take out the GCF of each. Okay, and I know this is review for us. Okay, so with this one, you can only take out x squared. When you're taking something out, you're dividing. So 2x cubed divided by x squared is going to be 2x. Anything divided by itself is 1, and then because you have a negative there, it's going to be 2x minus 1. Remember that when you're doing this, you want the same expression inside the parentheses. So that's why we're going to take out a negative 9. So this becomes 2x minus 1. Okay, so you need the same expression inside your parentheses. If that happens, your next step is the distributive property. What you're doing is you're taking out the GCF of both of these. Do you see how 2x minus 1 is in both of those factors? So if you were to divide that out, you would be left with x squared minus 9. Okay, and then we do have to make sure we factor this all the way down when it says to leave it in factored form. So you do have a difference of 2 squares here, so we're going to factor that down one more time. So you have x plus 3, x minus 3, 2x minus 1. Okay, I am going over this kind of fast because I know it's something you've seen multiple times. Okay, so let me know if you guys have questions on that, or if you need me to slow down. We just need some more reminders. And then just like we did before, we're going to set each factor equal to 0 to solve. So x plus 3 is 0, x minus 3 equals 0, or 2x minus 1 equals 0. Okay, so your zeros are negative 3, 3, and then here you would add the 1 first, then divide by 2. Okay, now one thing you can also use to help you is the fundamental theorem of algebra. Remember, whatever the degree is also tells you something else. Do you guys remember? Yeah, how many zeros? So see how this was x cubed? Okay, so you should have those 3 zeros. Okay, and then for this one, same thing, you should have those 3 zeros. Okay, and you can always find your real zeros that way. Okay, so for example 3, we are going to use our graphing calculator. We're going to graph the polynomial and determine how many local maxima and minima it has, and then round it to decimal places where appropriate. Okay, so I'm going to give you the polynomial so you can graph that. All right, and then I'm just going to make sure I'm in my standard window. Okay, so on the graph, you can see you have 2 local minima, so 2 local places where you have a lowest value, and then 1 local place where you have a maximum value. Do we remember how to do this on our graphing calculator? Okay, so we're going to find all of our values. Okay, so we're going to go to second calc, and then if you want to, it doesn't matter which one you find first. So you are trying to tell it to look in between 2 values. So I always try to get right on that minimum, and then I just arrow 1 or 2 to the left, go back to the center, 2 to the right, okay, and then you can make your guess. Okay, and then for this one, they do want you to write your minima as a point, and it says to round to the nearest hundredth. So 1.58, negative 2.25, and then we can go find our other minimum. Okay, so the left bound, the right bound, and then we can guess. I always like to put mine right on there to guess. You don't necessarily have to in order to get the correct answer, but you know that you have the right one when it says the minimum there. Okay, and then I'm going to give you guys a moment to do the maxima. So this time, choose the maximum on your graphing calculator. Okay, and this time it did give me a 0, 4, but remember, sometimes when you do this, you might see that e to a power, and that's just rounding to 0 as well. Okay, so if that happens. So this is not only a local maxima, it's also your what? Yeah, your y-intercept. Okay. And then, so we're not going to do this as a exit slip. I'm going to do it with you because you're going to need it for your homework. Okay, so we're going to talk about the area and volume of a rectangular prism below. So I want you to see, if you can do 1 or 2. You can work with your row, and then we're going to try to draw a visual here. I kind of feel like we did this last year. Okay, so what's your area for a rectangle? Good. Or base times height, whatever you prefer. Okay? Doesn't matter. Whichever one you put is great. Okay, and then the volume? Length times width times height. Great. Okay, so you have a piece of cardboard that's 10 inches by 8 inches. So let's just draw that first. Doesn't have to be to scale. Mine is not. Okay, so then what you want to do is cut X inches from each side to make a box. So let's think of each side separately. So let's do this side first. So if you cut X inches, it doesn't matter which part you cut your X inches from. Okay, I'm going to cut that strip. Okay, now if I do it from this side, again, it doesn't matter where you cut it. So if you cut it here, X inches. And then do you guys think you can do the other two? Yes, you can. So we cut X inches from this side, X inches from this side. So if this is cut off, now I have to cut off X inches from the other side. And then I have to cut off X inches here. Okay, so what you're doing is you're really making like the bottom of a cardboard box. So basically, if I'm cutting this value off, I'm cutting these corners so that I can fold this up, okay? So if I cut these corners out, did I do this last year? Okay. Well, I did, but I just did it with my pre-calc class. So we did this. Okay, so if I cut X inches from both sides, I'm doing that so that this folds up to make a nice little box here. And really doesn't have a top to it. Yeah, so we don't know what the x value is, okay? So now, if I fold each of them in, what we have to do is we have to figure out what this value is, this area. Sorry, it's not really showing up on the thing as well. But all we did is we folded each one in here, okay? So now we have like a little tray. Make sense? Okay, so then what would I call this? Do you guys know? No, I mean in numbers, but yes. You guys think about it for a minute. I'll come around. You guys talk about it with people. So we're going to try to figure out a name for this side and a name for this side. Okay, so we want something that represents the area of this base. Don't we have numbers and variables? So come up with an expression for the length and the width of the base. Okay, so if the whole thing was 10 to start with, I cut off what from each side? This whole thing was 10, but what I cut off? X. So this is going to be 10 minus, how many times did I cut off X from this side? Just, I cut off here and I cut off here, right? So twice. So this is going to be 10 minus 2X. Okay, and then this side is going to be 8 minus 2X. Okay, so write an expression that deals with the area. Well, the area is your length times your width. So 10 minus 2X times 8 minus 2X. Okay, and you could FOIL that out or you can keep it like that. Now, what is the height of the box? So look at what I have here. The height, when this stands up, is what? Yeah, it's X, because remember this was length of X, so that is now your height. Okay, so that is going to help you with one of your homework problems, okay? And then I am going to go over questions from your preview packet and yesterday's homework. If you feel like you don't have any questions on that, then I will let you get started on this. But I do have some specific directions for you. So for 27 through 34, in the book, they ask you to sketch the graph. You do not have to do that. Okay? So you do not have to sketch. You guys were worried I was going to give you more to do, weren't you? Never. Okay, and then for 41 through 46, the directions are a little bit different. All I want you to do for 41 through 46 is find the end behavior. Okay, so for those, just do the end behavior. You can do it exactly how we did in here. You don't have to graph it. You can just use what I showed you. Okay, and then no special directions for those. Okay, and then we're going to go over questions now on 3.1.